My dear students, my name is Prakash Shetty, lecturer in physics. I am from Government PU College, Banvalli, Hiriyar Taluk. So today we are going to discussing on electromagnetic induction chapter for your CET and NEET coaching classes. So here we are going to start to discuss about the synopsis part in today's class about the chapter electromagnetic induction. Here in the previous chapter, we know about the electric current and as well as the effect of electric current. It is when there exists a current in a conductor, whatever may be the shape. It may be straight, it may be just like an element, or it may be loop, or particularly regular or a circular loop. If it is going to be carries current, then there exists a magnetic field. This was get discovered by Weierstedt. So Weierstedt first discovered such that if there exists a conductor which is going to be carries a current, then there exists a magnetic field surrounding to this. In the surrounding place, the magnetic field is going to be exist. And to find the value of this magnetic field, different formulas and laws will going to be we had already studied. And the next chapter of this one is this electromagnetic induction. In the electromagnetic induction, the converse effect we are going to be observing. The previous chapter, if there is a conductor carries current, then there exists a magnetic field. If I exist, then magnetic field is going to be exist. The next one is it reverse is possible? Means if there exists a magnetic field, then is it possible to get the value of electric current? Why we are going to be demanding this one is because always we require the energy, and the energy it should be always convenient for us. And among the different forms of energy, electric current is the very convenient form of the energy for us. As a result, this electromagnetic induction phenomena is going to tells about how we can get the electric current by the help of the magnetic field. So before discussing about this electromagnetic induction phenomena, we're going to come across whatever the things we studied in the previous chapter about the magnetic field. So here, among them, the one of the physical quantity that we studied is a magnetic flux, which is represented by phi b. So what do you mean by magnetic flux? Magnetic flux is nothing but the number of magnetic field lines that are going to be crossing a given area in a normal direction. That is going to be measures the magnetic flux through that surface. If we are going to take a coil, and if it is going to be moved in a magnetic field, then certain number of magnetic field lines they are going to be passed through that coil. How many number of magnetic field lines they are going to be passed out of that surface of the coil in normal? Normal means perpendicular direction. That is going to be measures the values of the magnetic flux. So here, suppose if I am going to take a magnet, let us consider this is south pole and north pole of the magnet. We know that magnetic field lines they are going to be exist from north to south. So they are going to be exist from north to south in this direction. For this, suppose if I am going to hold a surface such that in any manner, then from this surface, when we are going to be observing from front view or the opposite view, certain number of magnetic field lines are going to be entering. That number of magnetic field lines enters through this surface is going to be decided as the value of the magnetic flux. And the equation for that magnetic flux is going to be given by phi b is equals to BA into cos theta. Phi b is equals to BA into cos theta, where phi b stands for magnetic flux, B stands for strength of the magnetic field, A stands for area of the surface. Here we taken in the diagram, this one is the area. And theta is the angle between the aerial vector of the surface and as well as the direction of the magnetic field. And observe in this equation, at the RHS, there are three terms. Among that, B is the strength of the magnetic field, which is a vector quantity. A is the aerial vector, that is also having the direction. Theta is the angle between those two. So as a result, we can write this one as B dot A in vector form. So product, that is a scalar product between the two vectors. B is their magnetic field, A is the aerial vector. Aerial vector is always normal to the surface, irrespective of orientation. Whatever may be the orientation of the surface, the direction of A is always perpendicular to the surface. That is direction of A. If you are going to consider this surface, then this will be the direction for A. If you are going to consider this surface, then this will be the direction of A. Like that, whatever the surface we are going to consider, that is going to give us the magnetic flux through that surface. And this magnetic flux, it is a scalar quantity. As already I told, it is a example for scalar product between the two vectors. And this was going to be get measured in terms of Weber. The unit of magnetic flux is going to be given by Weber, and another is Tesla meter square. Tesla meter square is the also the unit of magnetic flux. Now, from this equation, so when you going to take into consideration of the values, there are different cases. The thing is, the first one, if theta is going to become 0, if theta is equal to 0 or 180 degree, ಈ equation ನಲ್ಲಿ, suppose if you are going to substitute, theta value is 0 degree or 180 degree, then magnetic flux phi b is going to be becomes cos 0 and as well as, that is theta value is when it is 0 degree or 180 degree, then cos value is going to becomes maximum, phi b value is going to becomes plus or minus VAB ಅಥವಾ B into V. And similarly, if theta value is going to be becomes 90 degree, if theta value is going to be 90 degree, in that case, magnetic flux is going to be given by 0 because cos 90 is equal to 0. So from this it is clear that in this case, the flux is going to be maximum, and in the second case, the flux is going to be the minimum. So when the flux is going to be maximum, when both, that is A and B, are either parallel or anti-parallel to each other, means the direction of magnetic field and the direction of aerial vector of the coil, if both are along the same direction or in opposite direction, then the magnetic flux is going to be maximum. The value is going to be given by AB. And if both are going to be perpendicular, if this is the direction of the surface and upward is the direction of the magnetic field, if both are going to be perpendicular to each other, in that case, the magnetic flux value is going to be minimum. And from this, flux value may be positive, negative, and as well as 0. All the three possible values are going to be exist. Next, we are going to be come across this electromagnetic induction phenomenon. Now, the question is, what do you mean by electromagnetic induction phenomenon? Here, as I told, is it possible to produce a magnetic, that is electric current, with the help of a time varying magnetic field? That was the cause. So, here, Michael Faraday and Joseph Henry, they discovered this phenomena. What is that phenomena? According to them, as the phenomena is going to be indicating electromagnetic induction. ಸೊ ಇಂಡಕ್ಷನ್ ನಾನು ಪ್ರೇರಣೆ ಅಂತ ಹೇಳ್ತೇವೆ ಕನ್ನಡದಲ್ಲಿ, ಇದಕ್ಕೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ವಿದ್ಯುತ್ ಕಾಂತೀಯ ಪ್ರೇರಣೆ ಅಂತ ಹೇಳಿ. So electromagnetic induction, whenever there exists a change in the magnetic flux or strength of the magnetic field linked with a circuit or a coil, then an EMF will going to get induced in it. That phenomena is going to be called as electromagnetic induction. ಯಾವುದಾದ್ರೂ ಒಂದು conductor, whatever may be the shape, either it may be straight wire or it may be a circular loop or it may be of any irregular one. If it is going to be present in a region of magnetic field such that strength of the magnetic field should going to be get vary, or at least the conductor should going to be goes on moving, or there may be a relative motion between both, then an EMF will going to be induced within that circuit or coil. That phenomenon is going to be called as electromagnetic induction. And this was going to get demonstrated by, as we studied in theory part, that is coil magnet experiment, and second one, coil experiment. I'm not going to go in detail with these experiment. Already we know that whenever we're going to be move a magnet towards or away from the coil, with respect to the help of the, that is a pole of the magnet, the coil is going to be get induced with a certain amount of voltage and as well as the current that is going to get recognized by the galvanometer. Now, here this in the electromagnetic induction phenomena, as Michael Faraday and Joseph Penter, they are going to be discovered using these two experimentation. Then, what is the value of the EMF that is going to get induced, and what are the mathematical terms or the equations that are going to be helpful to measure the value of the induced EMF. Now, let us consider if there is a magnet which is going to be moving towards or away from a coil. Let us consider the coil is going to be stationary. Then an EMF is going to get induced as a result. There is the value of a current within this. How much value of the EMF? EMF stands for electromotive force, that already you studied in current electricity chapter. If there exists a EMF, automatically they will going to get the electric current. Here, if the EMF that is induced voltage exists, automatically induced current also we are going to getting. So when the magnet is going to be moving towards or away from the coil, irrespective of the pole, either north pole or south pole, we are going to observe this phenomena, that is electromagnetic induction. How much amount of current or voltage that is going to be exist, that is going to be given by mathematically, that is E is equals to minus d phi divided by dt of V. So observe the LHS E stands for EMF, that is induced EMF in electromagnetic induction, and phi B, delta phi B or d phi B. D phi B stands for change in the value of the magnetic flux in a time interval of dt. And if the coil is going to be having the many turns, then the equation is going to be written as minus n into d phi B divided by dt. N stands for number of turns in the coil. And the other forms of this equation is also going to be given by minus n d phi B can be also written as phi1 minus phi2 divided by time t1 minus t2. So this is also the other form of the equation for induced EMF. So as E is equals to minus d phi by dt, it is a basic mathematical equation for electromagnetic induction or Faraday's law of electromagnetic induction. So in the theory part, already you learned these equations. Just for competitive exam, d phi means the difference in the value of the magnetic flux value, and as well as T1, T2 stands for time interval or time before increasing or decreasing the magnetic field, and the T2 is the time before decreasing or increasing the magnetic field. And those are the terms that are going to be involved in this equation. Now, in this equation, as we are going to be come across this sign, that is minus. This minus term is going to be exist. What that term minus is going to be indicates? Here in physics, we will going to use this minus symbol for three purposes. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 3 is for multiplication, 2 is for addition, 3 is for subtraction. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for addition, 3 is for multiplication. 1 is for subtraction, 2 is for ad Another is for indicating the value is going to be decreasing. And another is to indicate the direction is going to be opposite. So here, in this case, we will going to be used for this purpose, that is opposite. So what do you mean by that? E equals to minus d phi by dt. In this electromagnetic induction phenomena, the cause which is going to be producing an EMF, it is going to be always get opposed by the coil itself. For example, suppose if you are going to be start to move the north pole of the magnet towards a coil, then at that time, this is also going to be act as north pole itself. The face of the coil, the surface of the coil, which is facing the north pole of the magnet. If the magnet is moving towards the coil, then this is also going to be act as north pole. Reason, it opposes the moving of the magnet towards the coil. We know that from the basic level, north pole and north pole, they're going to be repel with each other. So they're going to be opposed. So what it is going to be opposes, as I told now, when magnet is moving, due to that, an EMF is going to be get induced. And this induced EMF will going to be opposes the motion of the magnet, either towards the coil or away from the coil. And this was going to be explained by Lenz. So that is Lenz's law. So what the Lenz is going to tell? The cause which producing an EMF or current will always opposes that is going to be producing itself. ಯಾವುದು ಕರೆಂಟ್ನ ಅಥವಾ ವೋಲ್ಟೇಜ್ ಅನ್ನ ಇಂಡ್ಯೂಸ್ ಮಾಡುತ್ತಲ್ಲ ಆ ಪ್ರಕ್ರಿಯೆಯನ್ನ ಆ ಕರೆಂಟ್ ಮತ್ತೆ ವೋಲ್ಟೇಜ್ ಅದನ್ನ ಅಪೋಸ್ ಮಾಡುತ್ತೆ. ಅದನ್ನೇ ದಿಸ್ ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಇಂಡಿಕೇಟೆಡ್ ಬೈ ದ ನೆಗೆಟಿವ್ ಸಿಂಬಲ್. Now, when we are going to be using this electromagnetic induction phenomena, we are going to be come across many of the cases to track the questions from competitive exam. So we should we should know about the different cases when we are going to take into consideration of north pole and as well as the south pole and as well as the about the magnetic field. Observe here in the previous chapter, all of you know that magnetic field is going to be represented either by cross mark or dot mark. If you are going to put or if you are going to write any cross mark which are going to be equidistant on any paper or board, as I am writing now, this indicates the magnetic field is going to be uniform. Or another way, even you can write in the dotted form. ಈಗ ಡಾಟೆಡ್ ಫಾರ್ಮ್ ಅಲ್ಲೂ ಕೂಡ ನೀವು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. If the dots and cross which are going to be uniform and equidistant, they are representing magnetic field is going to be uniform. As magnetic field is a vector quantity, so which is represented by B. So what is the direction? As I wrote now on this board, the board ಮೇಲೆ ಬರೆದಿರೋ ಪ್ರಕಾರ, what the LHS left part, this cross mark is indicating the direction of the magnetic field is perpendicular to the board and directed towards the board. ನಾನು ಪೆನ್ನಿನ ತುದಿನೇ ಆಗಿಡ್ತೀನೋ ಹಾಗೆ ಆರೋ ಮಾರ್ಕು ಟುವರ್ಡ್ಸ್ ದ ಬೋರ್ಡ್ ಇದೆ ಅಂತ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋಬೇಕು ಅಥವಾ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ವೇರ್ ಎವರ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಅಬ್ಸರ್ವ್. Even if you are going to be observed the same diagram in notes or on the board or even in the question paper, you have to remember the direction of the magnetic field is perpendicular to the plane of the paper or plane of the textbook and directed towards the board or paper. And this is going to be reverse. Reverse means only direction is reverse. Values are going to be same. Whatever the strength of the magnetic field is here, the same strength will be there. The direction is opposite. That means the direction of the magnetic field is perpendicular to the board, but directed away from the board or with frame of our reference as observer. In this case, the direction of the magnetic field is directed away from the observer. Here, it is directed towards the observer. So that thing you should going to be remember always. And using this, suppose if you are going to take the different cases, in case of a coil, when we are going to be move the magnet towards or away, just I will going to describe a table, write down that table which is going to be necessary to solve the numericals. So here, just I'm going to take a magnet in that north pole and south pole, and here just a coil. Suppose the coil is going to be start to move towards this, the magnet is start to move towards the face of the coil. ನಾನೀಗ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೆದಿರೋ ಪ್ರಕಾರ ಮ್ಯಾಗ್ನೆಟ್ ಹೀಗಿದೆ, ಕಾಯಿಲ್ ಇನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದೆ, plane of the coil. This is another surface, but we are going to be discussing about this surface only. That is the face of the coil, which is facing towards the magnet. Now, according to Lenz's law, this should going to be get opposed. As it is going to be get opposed, then it should going to be act as a north pole. As it is going to be act as north pole, so this is going to be the direction of induced current, induced current direction. So as a result, induced direction current is, as we are going to be observing, it is in anti-clockwise direction. Anti-clockwise direction. And what about the nature of the force? So the nature of the force, when the magnet is going to be moving towards the coil, automatically the number of magnetic field lines value is going to get increases, flux value is going to be get increases. As a result, the force is value is going to be get increases between both. This is also going to be acting as north pole. This is also going to be act as north pole. So the force is going to be repulsive. Force between north pole of the magnet when moving towards the coil, then that face is going to be opposes. As a result, it is going to be act as repulsive. Similarly, suppose if you are going to take the north pole of the magnet, which is going to be moving away, means it is taken away from the coil. At that time, the coil is going to be start to act as it is going to be moving, it should going to get opposed. So then it is going to be start to act as south pole. ಆವಾಗ ಇದು ಸೌತ್ ಪೋಲ್ ಆಗಿ ಆಕ್ಟ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. In that case, the direction of the current, this is the direction of the current. So as a result, and the direction of the induced EMF ಅಥವಾ induced current. So this will be the direction of the current. So as the direction of the current is appear to be just like clockwise, so it is going to be appeared as clockwise. Now, as this one is the north pole. North pole is moving away, but south pole is going to be opposites. Means then the nature of the force is going to be attractive in nature. Then it's going to becomes attractive in nature. So like this for other phase also. That is when you're going to take on the south pole, and if you are going to moving it towards or away from the coil, accordingly the coil is going to be start to behave. ಅಂದ್ರೆ ಸೌತ್ ಪೋಲ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನು ತಗೊಂಡು ನಾವು ಕಾಯಿಲ್ ಕಡೆ ಮೂವ್ ಮಾಡಿದಾಗ, ದಿಸ್ ಸೌತ್ ಪೋಲ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ, this surface of the coil is going to be behaves as south pole. As both are going to be south, they are going to be repulsive with each other, and we are going to want to take it away. When you want to take it away, then this is going to be south pole, this is going to be start to act as north pole, then the force is going to becomes attractive, and accordingly S and N, you have to write it in within the circle easily, then you can identify whether it is going to be clockwise and as well as anti-clockwise. And remember this throughout your competitive exam, it is going to be helpful, and even for the board exam also, if they are going to ask any questions in multiple choice, then that's a simple one that is going to be helpful to find the correct answer. Next one. This equation, that is E is equals to minus N into d phi by dt. Sometimes this is also going to be called as Newman's relation. ಇದನ್ನ ನ್ಯೂಮನ್ಸ್ ರಿಲೇಷನ್ ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. ಮೈಕಲ್ ಫ್ಯಾರಡೇಸ್ ಲಾನು ಕೂಡ ಹೌದು, Lenses lanu kuda avadu. Lenses is going to tell only about this, and Newman's is going to tell about the equal, that is proportionality constant that will going to be exist. That proportionality constant is going to be equal to 1. So when you going to substitute, then the complete equation is going to become E equals to minus n into d phi by dt. This is going to be called as Newman's relation. Now, using this concept, suppose if you are going to start to make a movement of a particular conductor within the magnetic field, then either any EMF will going to get generated within that or not. So then we will going to become across motional EMF. Now, as the name indicates, a motional EMF. EMF induced in a conductor or a coil due to its motion within a magnetic field. Now, the theory part also already all of you had found the equation for or derivation for this one. So, suppose if a conductor of any shape, let us consider a straight conductor, I will going to take PQ. If it is going to be start to move in a direction such that, as I told, it is going to be perpendicular to the plane of the board. So direction of B is within this. Suppose if it is going to be start to moving with certain velocity V, then is there exist any amount of induced current or magnetic, the induced current and as well as the induced voltage. That voltage that is get developed within the conductor due to its motion within this magnetic field, that is going to be called as motional EMF. And that motional EMF is going to be given by E is equal to BV into L, where B stands for strength of the magnetic field, V stands for velocity with which the conductor is going to be moving, L stands for length of the conductor. So observe from this equation, for a given conductor, L is going to be almost remains constant, and for the applied magnetic field, B value is going to be remains constant. Then it morely depends only on the value of velocity. Suppose if coil is going to be held stationary, coil is held stationary andre adu move ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ಹೀಗೆ ಇದೆ. Is the motional EMF exist? So ಹಾಗೆ ಸ್ಟಾಪ್ ಇದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? It is at rest. So when it is at rest, then the V value should going to be 0. When you are going to substitute V value is going to be 0, then this equation is going to becomes E is equals to 0. That means no EMF is going to get induced within a straight conductor or any shape of the conductor if it is at rest, even though it is present in a magnetic field. Magnetic field ಅಲ್ಲಿ ಇದ್ದು ಕೂಡ ಅದು ಮೂವ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ then there is no arise of motional EMF. And here, as I told, the value of the EMF that is going to get generated, how to find the value of the different physical quantities like current, charge, and as well as the power. So here we're going to become across the main equation as E is equal to minus n into d phi by dt, d phi b divided by dt. So this is for induced EMF. Induced EMF. So when you want to find the values of the current, we know that from the Ohm's law, V is equals to I into R. So from this equation, I is can be written as V divided by R. So at the point place of V voltage, we can substitute the value of the EMF that is going to be induced. Then the equation is going to become minus N divided by R into d phi B divided by dt. This is for induced current. The value of induced current. So similarly, is there exist any power? We know the equation for power as power is equal to product of voltage and as well as the current. So this will be equal to, at the place of voltage, if you're going to substitute the value of E, then you're going to get minus N into d phi divided by dt into I. I value as I told here. Now again it is going to becomes in the bracket minus N by R into again d phi B divided by dt. So again further if we're going to simplify, then the equation is going to becomes minus into minus plus n into n square. Here R is there, divided by R. D phi by dt into d phi by dt. It is d phi divided by dt whole square. This is going to be the equation for induced power. So I request all the students just to note down the at least formulas which are going to be helpful to solve the numericals and as well as the questions that are going to be upcoming for the next classes. The reason is in the competitive exams, don't think they're going to be simply asked the problems or any questions directly from the direct formula. They're going to be expect more. So they may be asked to calculate the value of the current and as well as the power also. So using the basic things only, we can find the equation. In this case, power dissipated. So power dissipated in what form? Power is going to be dissipates in the form of the heat or at the rate of heat. In that case, the equation is going to be given by P equals to H divided by T. H stands for amount of heat generated. Artha, when a magnet and as well as a coil or any conductor, they are going to be moving or there exists a relative motion or continuously there exists a electromagnetic induction phenomena. Then voltage is going to be get induced, current is going to be get induced. Automatically, we know that the effect of electric current among them, the one is heating effect. So heat is going to be get generated. That heat generated is going to be dissipated in the form of heat. That is going to be called as the power loss. So how much amount of power that is going to get induces? But also you can calculate using this equation P equals to H by T. So for power in terms of number of turns and resistance, in terms of heat and as well as the temperature, in term heat and as well as the time, not temperature, and in terms of voltage and as well as the current. So these are the equation for induced power. So next one is we're going to become across about the self-inductance. Self-inductance. Here, we're going to be observe the effect of magnetic field produced due to conductor carries the current. That is as explained by Weierstedt. And next about the EMF induced in the coil due to changing in its magnetic field. That is the explanation of both Weierstedt and as well as the Faraday laws. Here, self-inductance. Self is only one. So if there is a conductor which is going to be carries a current, and let us consider it is going to be in the form of a coil. So this is going to be called as inductor coil. Let its self-inductance is represented by L. Suppose if you're going to pass a current through that, then in order that if you're going to draw the graph for current versus time by taking current versus time, then the nature of the graph, how it is going to be appears, it is appears when going to take into consideration at the beginning, when going to allow the current, then the value of the current gradually goes on, increases and becomes constant. So later, the values of the current is going to becomes constant. And again, after a certain time, suppose if you're going to remove the current, then the value of the current is going to be goes on, decreases. Observe in the graph this portion. That is, I will going to give the name for this as OAPC. So O to A is going to be called as growth of the current. And A to B current is going to be constant. Constant current exists. constant current. And B to C, decay of the current exists. O ಇಂದ ಎ ಪಾಯಿಂಟ್ಗೆ ಹೋಗ್ತಾ ಹೋದಾಗ ಕರೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಎ ಇಂದ ಬಿ ನಡುವೆ ಕರೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಬಿ ಇಂದ ಸಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. During growth of the current, already we showed in the previous chapter, if current will be more, then magnetic field produced is going to become more. So B is more. B increases. And here, if current is constant, then B is also constant. B is equals to constant. And if current is decreased, then B is going to be less. B is going to be less. Now, we come across about this electromagnetic induction. Observe, when we take into consideration of all the three at the time of growth of the current, when the current is constant, and as well as decay of the current, here B is going to be changing. And now only we know that magnetic flux is going to be given by BA into cos theta. If B value changes, then phi B value is going to be exist. If phi value is going to be exist, then exist an EMF, which is going to be given by E equals to minus N into d phi divided by dt. So observe, whenever the B value changes, here B value is going to be changes in two cases, at the time of making the circuit and as well as breaking the circuit. So that is at the growth of the current and as well as at the decay of the current. And at this region, that is when the current is constant, we will not going to be observe the change in the value of the magnetic field. As it remains constant, then flux remains constant. If flux remains constant, you can't observe the phenomena of electromagnetic induction. Flux, when it is going to be get changes, either it may be increase or decrease. So then you will going to be observe the value of this electromagnetic induction. So due to this self-inductance, an EMF induced in the coil due to growth or decay of the current is going to be called as self-induction. And that ability is going to be called as self-inductance. And that self-inductance is going to be depends, which is going to be given by the equation induced EMF E is equals to minus L into di by dt. Again, L stands for self-induction and di stands for change in the value of the current. So change in the value of the current exists in first case and as well as the third case. Dt is the time taken to change the value of the current. And also the how much amount of EMF that is going to get induced, that is the depends on the value of the flux. Flux value depends on the value of N, that is number of turns in the coil. So we can write this one as the value of flux and number of turns and self-inductance and as well as the current. The equation is L is equals to N phi divided by I. Remember, these are the equations for self-inductance of a coil. We are going to taken. So E stands for induced EMF, L is self-inductance, bi by dt, rate of change of electric current. In this equation, N stands for number of turns of the coil. So these two are the main equations for self-inductance of a coil. When it is going to be induced, an EMF again going to be get generated within the coil. That's why the EMF induced in the case of self-inductance, it is also going to be called as back EMF. So ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆದಂತ ಅಂದ್ರೆ ಅಪ್ಲೈ ಮಾಡಿದಂತ ಕರೆಂಟ್ ಇಂದ ಮತ್ತೊಂದು EMF ಸಿಗ್ತಾ ಇರೋದ್ರಿಂದ ವಾಪಸ್, ಹಂಗಾಗಿ ಅದರಿಂದ ನಾವು ಬ್ಯಾಕ್ EMF ಅಂತ ಹೇಳ್ತಾವೆ. ಸೊ ಬ್ಯಾಕ್ EMF exist in self-induction phenomenon. Now, due to this, it is going to be carries any amount of energy. So ಈ ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್ ಇರೋದ್ರಿಂದ ಇದರಿಂದ ನಮಗೆ ಯಾವ್ದಾದ್ರು ಎನರ್ಜಿ ಸಿಗುತ್ತಾ? Energy is also going to be exist. That also you studied in the theory part, that energy carried by a self-inductor is going to be given by U is equal to half Li square, where L stands for self-inductance of the coil, and I stands for current through the coil. So this much amount of energy is going to be get stored, or that is going to be get generated in the case of self-inductance. And this self-inductance, that is L, is going to be measured in terms of Henry. H or Henry. Henry is the SI unit of self-inductance of the material. Along with that, here, as I told, the whatever may be the shape of the conductor, either it may be straight, or it may be just like an element, or it may be of any irregular shape, or it may be of regular like circular shape. Now, suppose if you are going to take the particular shape of the conductor that already we shared in theory part, that is the solenoid. So when you are going to take the case of the solenoid, then is the electromagnetic induction phenomena is possible. Of course, it is going to be possible. When you are going to take a coil that is just like a solenoid. So we know that solenoid means a coil which is going to be carries a current in particular direction. Automatically there exists a magnetic field along the axis of the coil. Due to change in the magnetic flux at the center of the coil, the magnetic field strength is going to get varies. When the magnetic field strength get varies, then magnetic flux value is going to get varies. In this equation, we know that the magnetic field at the center of the magnetic that is solenoid is going to be given by B is equals to mu naught N into I. Is it act as self-induction? Of course, this is also going to act as self-induction. And in that case, we know that it is going to be carries the energy. How much? U equals to of Li square. And the self-inductance is of a solenoid is going to be given by the equation L is equals to mu naught N square A into L, where mu naught stands for permeability of free space, N stands for number of turns per unit length, A stands for area of cross section of the solenoid, L stands for length of the solenoid. If you are going to substitute and equate in this equation, then the equation for energy stored in a solenoid is going to be given by of L. Here the of L ಜಾಗದಲ್ಲಿ ನಾವು we can substitute the equation as mu naught N square A into L into I. From this equation, B is equals to mu naught Ni. Therefore, I is equals to B divided by mu naught N, and it's a square, Li square. So if you're going to simplify, then the equation is going to becomes of mu naught N square area into length into, and in the bracket term, B square divided by mu naught square N square. So if you're going to simplify, then this N square gets cancelled, and single mu naught gets cancelled. Then we remaining the terms as in the numerator area length into B square, area length into B square in the denominator 2 mu naught. Here A into L. A stands for area, L stands for length. Then this can be written as B square into V divided by 2 mu naught. What do you mean by V? V stands for volume. As volume is equal to length into breadth into height. This amount of energy is going to be get generated in a single solenoid. So if you're going to found if you want to find the equation for energy per unit volume in the case of the solenoid, then the equation can be written as U divided by V. Send this V to the LHS, then it's going to becomes we remain RHS term of B square divided by mu naught. ಇದು ಕೂಡ ಒಂದು ಡೈರೆಕ್ಟ್ ಇಕ್ವೇಶನ್ ನಿಮಗೆ ಬೇಕಾಗುತ್ತೆ. ಜಸ್ಟ್ ನೋಟ್ ಡೌನ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಪರ್ ಯೂನಿಟ್ ವ್ಯಾಲ್ಯೂಮ್ ಆಫ್ ಎ ಸಿಂಗಲ್ solenoid in due to the self induction phenomenon. So the next one, we're going to come across the next phenomena that is going to be called as mutual inductance. Which is represented by M. Mutual means there should be two conductors of any shape. Either both may be of straight wire, or one is going to be of straight and another is going to be of circular ring type. So if there exist two coils, just like as we know in the case of coil experiment, if there exists growth or decay of the current in one coil, due to that, due to the one which is in linked with another link, means not in contact, but they are going to get separated, but near to the vicinity, means very closer to each other. Due to the variation of current in one conductor, there exists a EMF in the another conductor. That is going to be called as mutual inductance. So mutual induction phenomena can be defined as the phenomena in which the change in the value of current in one coil with respect to the another coil, and in that another coil an EMF is going to get induced. That is going to be called as mutual inductance. And that mutual inductance equation here also, it is similar to self inductance. Here E is equals to minus M into dI divided by dt. Again, M stands for mutual inductance, dI by dt indicates the rate of change of the current with respect to time. So, in the case of two coaxially coaxial solenoid, let us consider a solenoid which is a coil which is present inside, and as well as another coil which is going to be written over like this. So then this is going to be consist of two coils which are going to be coaxially. Coaxial means their axis is going to be common. So let us consider their axis is going to be this one, which is common to this. So if I am going to be pass the current in one solenoid, automatically another solenoid is going to be induces with an EMF. So in that case, how to calculate the value of that induced EMF? That is mutual inductance. That mutual inductance in this case is going to be given by M is equals to mu naught mu R into N1 into N2 into A1 into R1. Okay. So what do you mean? What are the terms stands within this equation? Directly I indicated the equation. So mu naught stands for permeability of free space. Mu R stands for relative permeability between the two solenoid. N1 and N2 stands for number of turns per unit length in the first coil and as well as the second coil. ಯಾವ first coil which is present inside inner coil, and N2 stands for number of turns per unit length of the outer solenoid. A1 stands for area of cross section of the inner solenoid. R1 stands for radius of the inner solenoid. And observe in this equation, if any medium is not there, that is only vacuum exists, then you have to neglect this term. ಈ ಟರ್ಮ್ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಆವಾಗ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಕೋಆಕ್ಸಿಯಲಿ solenoid is going to be given by M equals to mu naught N1 N2 A1 into R1. And this equation holds good only when both are going to be coaxially cylindrical form. If they are going to be orient, ಒಂದು ಇನ್ನೊಂದರ ಜೊತೆಗೆ ಸಮಾಂತರದಲ್ಲಿ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ then you can't apply this equation. That also you should going to be remember, that is the condition to use this equation to describe any equations or to evaluate any values using this formula. So the next one is AC generator. So what I mean by AC generator? It is a device what it will going to move? It will going to made if there exists a mechanical energy. It is going to get converted into electrical energy. So, basic definition of AC generator. AC generator is a device which converts mechanical energy into electrical energy. And on what principle it is going to be works? Principle of the AC generator is again as the name of this heading of the chapter, that is EMI, electromagnetic induction. So when I'm going to be observe this AC generator, just roughly I'm going to write the diagram. So here there exists a rectangular coil which is going to be easy to rotate about the its axis in one particular plane, and it is going to be present within a magnet or magnetic field. Here, suppose if you're going to return concave shape magnet, you can say this is North Pole and this is South Pole. And if this coil is going to be free to rotate about an axis with certain angular velocity, let it as omega. And if it is going to be made to rotate, then automatically this coil is going to be present within a region of the magnetic field in which strength of the magnetic field is going to be get varying continuously. So here magnetic field lines exist from North Pole to South Pole. So when the coil is going to be start to rotate, so automatically magnetic flux linked with this coil is going to be goes on changes. As a result, an EMF is going to get generated. That EMF is going to be given by the equation E is equals to E naught sine omega t. And this equation is in the form of y is equals to A sine omega t. And we know that in first PUC, this is the equation for simple harmonic motion. Due to the simple harmonic motion, if we are going to draw the graph, then the nature of the graph is going to be sinusoidal in nature. So by taking the value of the displacement along y-axis and time along the x-axis. The same thing here also going to be, we're going to be come across. Then EMF is going to get induced or generated within the coil. As there exists a induced EMF, that EMF value is going to get changes according to this equation. So EMF value is going to get changes periodically. Sometimes it is going to vary from minimum to maximum, and again then maximum to minimum. That is going to get continuous. So in this equation, E equals to E naught sine omega t. E stands for instantaneous EMF that is going to get induced at any time interval. E naught stands for maximum EMF that is going to get generated. This is omega. Omega stands for angular velocity of the coil. And here we taken the coil is going to be rotating uniformly. Means omega is not going to be varying. And t is the time at which we want to calculate the value of EMF that is going to get induced. And what about the values of the current? As this is the value of the voltage, then current is can be written as the equation is given by I is equals to I naught into sine omega t. Okay. And here in this equation, E naught is equals to given by NAB into omega. So remember this E naught maximum EMF. Now first PUC leno amplitude ಅಂತ ಹೇಳಿ ಕಲಿತಿದ್ವಲ್ಲ simple harmonic motion. ಅದರ ಇಲ್ಲಿ what is the maximum value of the voltage that is going to be get induces in a coil which is going to be present in a generator that is given by NAB into omega. And here that N stands for a number of turns. N stands for number of turns, and A stands for area of cross section of the coil. B stands for strength of the magnetic field, and omega stands for angular velocity. So as a result, this is the equation for maximum induced EMF. Corresponding current is going to be given by I is equals to I naught sine omega t. Here, what do you mean by I naught? I naught stands for maximum value of the current. So that maximum value of the current that is going to be given by I naught is equals to V naught divided by R. That is using Ohm's law, or E naught divided by R. where R stands for the resistance of this coil. So with this, I want to conclude the today class for about the electromagnetic induction. In the next session, we're going to solve the numericals over this chapter. So be ready with the equations that I'm going to be explained in today class. So directly we're going to be come across the problems and we're going to discuss about the solution. Thank you.